We'll start a new chapter called the load characteristics now. Load characteristics. So, the first thing which will be coming in the load characteristics will be the load curve. Since we know that during a day we also consume a different load and different times. In the morning time when we are just awake, at that time the electricity consumption is very less. We go to office at that time we are using fan and tube lights and lighting arrangements or ACs. In the evening, everything is lit and we are using electricity on the full-fledged, and street lights are there and parking lights, park lights are there, and we have the whole home is lit by the lamps, the tube lights and all that. So one can understand that during the whole 24 hours we are consuming a different type of load. At the time we can have a general idea in that case, that is called the load curve. So if this is load during the day and this is the time in 24 hours, suppose. So in the morning we will be having small load, in the evening it will be more, and at the night it will be less and almost a constant. So we can have a different type of load. We can have a characteristic of different load curve also. We can have a load curve of like this also. Anything could be a load curve. So what exactly the load curve says? Load curve is exactly the load versus time. So anything which shows load versus time is called the load curve. So what is the use of the load curve? There are several uses of the load curve which we can discuss, which we'll be discussing. But if we look at the load curve right now, is the red curve. If I talk about the red curve right now, I can say that this is the maximum demand which I am looking for. This will be the maximum demand of my load curve, and this would be the almost a constant load which is always present in the system. Likewise, I can have the average demand also approximately here or the red curve. So from the load curve, I can have first of things called the load variations. Load variations are very much important. The study of the load variation is very much important in the design of the power system, such that when we have a power system generating plant, so since we have discussed this thing that rather than having a single uh, unit, suppose this is the maximum demand of 100 megawatt, right? Suppose, and average is 50 and the minimum is 30, suppose. So rather than making a 100 megawatt power system, power plant, I can have an average power plant, that is 50 megawatt power plant. Or I can do one thing, I can have a 10 megawatt of 10 different generating plant, 10 generating units, such that it is maximum demand is uh, fulfilled by the same system only. Or I can have an interconnection of the system also. If I talk about the 10 megawatt of 10 systems to uh, have a 100 megawatt of total power plant. So I can say that at this time the three my 3 generator will be working continuously, and for some time as the load is increasing, I'll switch on the generator, keep on switching on the generator, and at this point, I'll put on all the generator into the system so that it will be producing 100 megawatt. And when the load duration is going down, the load is going down, I can have the cutting of the my generating clients, and I can have base load which is the 30 megawatt at all time. So this is one of the reasons that rather than putting a 100 megawatt direct generator, I can have a 10 megawatt of 10 generator, so that as the load comes, we will put on the generator into the system. As the load is out, we are putting our generator off to the system, so that the maximum load factor is there. We will be discussing about the load factor also. So we are talking about the load duration, load variation right now. So we can have the load variation, and according to that, we can plan for the power system. From this curve, I can also say that I can have the maximum demand and the average demand. So I can have the maximum demand and the average demand. What is the use of the maximum demand? So the maximum demand will be this demand, which is right now the 100 megawatt, and the average demand is right now the 50 megawatt. So I can have the design of the power system in such a way that it will be able to supply the 100 megawatt power also, and it with efficiency, and it will be producing 50 megawatt of electricity or 50 megawatt of power with efficiency and with the reliability also. So the maximum demand and the average demand are very much important during the design of the power system plant. Coming to the parts of this load curve, is the area under the load curve gives the total energy generated. So if I say that this area of the red curve, which will be giving me this is the area under my load curve which is coming, so it will be giving me the total energy generated. So area under the load curve is equals to the total energy generated. Apart from that, one more thing comes. The area under the load curve and the area of the total rectangle is also important. Right now, the area of this rectangle is somewhat this much. So the area of the load curve and area divided by the area of the total rectangle give the load factor of the system. So area under load curve divided by the area of this rectangle is equals to load factor. What is this load factor? Load factor is the average demand upon the maximum demand, which will be same. So, but just for understanding this thing, what is the load factor here? What is load factor as called? Load factor is called as the average demand upon the maximum demand, or the ratio of average demand to the maximum demand is called as the load factor. So we can have the utilities of the load curve also, that we can have the total installed capacity, or we can have when the generation plant is under process, or when the gestation period is to be decided, and according to that, we have to decide the installed capacity of the system. So at that time, we will be looking at the load curve and we can say what should be the installed capacity of the system. Apart from that, it also gives the most economical size of the conductor, such that the conductor will be of which size it will be giving the economical size of the conductor by Kelvin's law, which we have studied. Kelvin's law, modified Kelvin's law. So according to that, we will have the most economical size of the conductor by the load curve. So this is also important. So the first thing which we can think of from the load curve is the installed capacity. Second thing which we can understand from the load curve is the most economical size of the conductor. Third thing which we can say about the conductor is the generating cost. About the power system is the generating cost we can find out from the load curve. How the generating cost is taken out? Since I said that I will be having 30 megawatt of system over here always present in the system. So that will be the base load and the peak load right now will be the 100 megawatt and average is 50. So rather than designing a system for 100 megawatt directly, I can have my power plant of 50 megawatt such that it will be able to cope up with the average demand of the system. Total if this is for my city, so I can say that for my city 50 megawatt is enough. So I will be designing a system of 50 megawatt and this part which is more than my 50 megawatt, this part which is more than my 50 megawatt part right now, I can have two things rather than having a 100 megawatt system, because see, we can see that this part is always empty, this part is always empty, this part, whole this part is empty. So we can say that rather if we design a system of 100 megawatt directly, which is the peak load, what will happen? Most of the system, most of the power plant will be shut and it will not be in use, and the expenditure cost of the system will be higher and the capacity of the system will be of higher cost and the generation cost will again increase. So rather than having this system of 100 megawatts, I have 50 megawatts system that will decrease my total capacity, since it depends on the capacity of the system, that if the capacity of the system is increasing, but obviously the cost will be increasing in the installation, and the installation cost is high and we can have the generating cost is also high, because we have to take that amount from the power plant only. So one thing which can be done is that I can have a 50 megawatt system and the rest 50 megawatt, which is right now this blue part, which is we are seeing right now, we can have the interconnection of the system such that when we are in need of the extra power, we can import it from some other station which is of higher capacity, which is having extra power, extra surplus power. So we can have this extra surplus power from them, so that the generating cost of my total system will be less, because my installed capacity is less right now. And one more thing will come, the load factor of my total system will be high at that time, and I will be using my system to the fullest, so that nothing will be kept idle, everything will be working. So that will be also affecting the generating cost at that time. So The fourth thing, very important thing which I'll be having from my load curve would be as the operating schedule. Operating schedule, as we have discussed this thing, just that since I can have a different type of system, I can have a 50 megawatt system, and I rest which is above 50 megawatt when it is required at that time, and we at that time we can have the interconnection. So I can have a 50 megawatt system, and I can have 10 cross 10 megawatt system also. I can have 5 into 10, 5 into 10 cross 10 megawatt system also. So it depends on the design of the system, and it depends upon the use of the systems, such that the economical is very much important. So operating schedule in this, when I am talking about the 10 into 10 megawatt system, at that time I will be switching on the system when they are required. At least 3 would be always present if 10 into 10 megawatt system is concerned, and then 4, 5, 6, so on 10, all 10 will be under the working condition at my peak load, and as the load is going down, I can have removal of my generators from the system. So I can have the operating schedules in such a way that the demand and fulfillment of the demand is balanced. That will be the load curve. So from this load curve, I can have a different curve which is called as the load duration curve also.